tricks and concepts on these will be discussed in this session. It is requested go through the session completely. Now let's start with the question and concepts. Question is, in a given time of 10 seconds, 40 electrons pass from right to left. In the same interval of time, 40 protons also pass from left to right. Is the average current is 0? If not, then find the value of average current. According to question, first of all, concept applicable. Conventionally, direction of flow of current, of electric current is opposite to that of flow of electronic charge. That is, direction of flow is direction of positive charge. Direction of positive charge. According to question, and I equal to Q by T. This you know. Now, right to left. Initially is right to left. This is right to left, 40 electrons, 10 seconds. Right? This is left. And this is left. This is right. These are 40 protons, 10 seconds. Now, conventionally, both directions will be considered as same. Both direction for the purpose of direction, both will be added. Both will be added. That is, current will not be 0. Right? Therefore, average current, I average, equal to Q electron upon time plus Q proton upon time. That is 40 E divided by 10 plus 40 E divided by 10. On simplification comes out to be 80. 80 means 8 into 1.6 into 10 to the power minus 19, as charge on proton equal to charge of electron. Same hota, but opposite in nature. That is, one is negative, one is positive. Charge on electron is negative, charge on proton is positive. On simplification, this comes out to be 1.28 into 10 to the power minus 19 Coulomb. This is the answer. Right? Next question. Question is, current in a wire varies with according to the relation I equal to 3.0 ampere plus 2.0 ampere per second to t. Means current is function of time. Current is function of time. How many coulombs of charge pass through cross section of wire in the time interval between t equal to 0 to t equal to 4 seconds? Second part, what constant current would transport the same charge in the same time interval? Right? Now, we know di equal to dq by dt. Right? Now, dq equal to I dt, as it is mathematical expression expression and is product. Therefore, integration will be carried out. Integration should be. If it is a ratio, then think of differentiation. Therefore, 0 to q dq equal to I3 plus 2, 3 plus 2t dt 0 to 4 seconds. 4 seconds. You know the formula? A to b x power n dx equal to x power n plus 1 divided by n plus 1. Upper limit minus lower limit. Bn plus 1 minus an plus 1 divided by n plus 1. This is applicable here. So this comes out to be dq equal to 3 into t plus 2t square by 2. 0 to 4. Right? Now 3t plus t square 0 to 4. 3, 4 minus 0 plus 16 minus 0. 12 plus 16, this comes out to 28 Coulomb. First answer is this. Part A answer. Part B answer, I equal to Q by T. 28 divided by time is 4 seconds, the same interval. What constant current would transfer the charge on the same interval time? That is 4 seconds. That is 28 divided by 4. That is 7 ampere. That is the answer of B part. Right? Now, next question. Question is, current passing through wire decreases linearly from 10 ampere to 0 in 4 seconds. Find the total charge flowing through the wire in the given interval. It is decreasing linearly. This is the x-axis. This is the y-axis. X-axis पे हमने time ले लिया. Y-axis पे हमने current ले लिया. 10 ampere. This is 0, 10. Reduces to 0. Reduces to 0 in 4 seconds. So current होगा 4 times 4 seconds. Right? Now, in this case, I equal to Q by T. We have to find the charge flowing through the wire in the Q equal to I into T. This is the product. This is the product. Question is graphical. Question is graphical. If product, think of area. If ratio, think of slope. Right? In this case, we will case this one. Now, therefore, charge will be equal to area of triangle OAB. OAB. That is half base OB into OA. That is half 4 into 10. This comes out to 20. This comes out to 20 Coulomb is the answer. 20 Coulomb is the answer. What is the requirement? Find the total of flowing through the wire in the given interval. That is the answer. Right? Next question. अभी तक के सेशन में हमने कॉन्सेप्ट एंड ट्रिक्स डिस्कस की ऑन दिस टॉपिक. Further, we are going to discuss on all these. It is requested to go through the session completely. Concept regarding resistance of a wire. Resistance of a wire for a given temperature depends on length and inversely proportional to the area. If we combine these proportional to L upon A, that is R equal to rho L upon A, where rho is constant of proportionality and is known as resistivity. It's around ohm meter. Ohm. Whenever we have to find the resistance, to find resistance, always 2 points or surfaces are defined. Here, in this case, are between P and no. L is taken as parallel to P and Q, and A is taken as perpendicular to P and Q. Right? For a given wire, if A is constant, we can use direct formula. If A is not constant, think of integration. Think of integration. Right? So, rho is constant for a given wire of material, and it depends on number of free electrons. If it increases, rho increases, right? 1 over rho is conductivity. This is regarding the resistance of a wire at a given temperature, right? Now let's start with the question. Question is, two copper wires of same length have got different diameters. Which wire has greater resistance and which has greater specific resistance? As we know, that R equal to rho L upon A, length upon area, for a given wire of length R proportional to 1 upon A. Means resistance is inversely proportional to area. Resistance is inversely proportional to area. Rho is same as both are of copper. Length is same. All taken into constant of proportionality. Now, therefore, resistance will be more that wire whose cross section of area is small, that is because thicker wire. That is enough. So second part is greater specific resistance. This will be constant for a given wire at given temperature. Right. Next question. Question is, a wire has resistance R. What will be its resistance if it's just double its length? First of all, I will discuss the concept applicable here. As same wire is being stretched, therefore mass will remain same. Therefore, M1 over M2 before and after stretch, that is equal to V1 rho 1 equal to V2 rho 2. This is before, this is after. As rho 1 equal to rho 2 for same material, therefore A1 L1 equal to A2 L2. This comes out to be L1 over L2 equal to A2 over A1. Now, depending on the requirement of the question, we can find the relations. You know, as R equal to rho L upon A, therefore R1 over R2 equal to L1 over L2 A2 over A1. Eliminating area. So this L1 over L2 equal to L1 over L2. This comes out to be R1 over R2 equal to L over L2 whole square. Therefore, R proportional to L square. Similarly, by eliminating length, R proportional 1 over A square and R power 4. If same wire is stretched, so R proportional to L square inversely proportional to A square inversely to R power 4. Now, according to question, R1 equal to R, R2 we have to find it out, L1 equal to L, L2 equal to 2L. Therefore, R2 over R1 equal to L2 over L1 whole square. That is R2 upon R equal to 4 is to 1. Therefore, R2 equal to 4R. This is the answer. Right? Next question. Question is, dimension of conductor of specific resistance rho are shown below. Find the resistance of conductor across A, B, C, D, E, F. This is the figure. Concept applicable and solution. We know R equal to rho L upon A. Here concept is being cleared how to identify area, how to identify length. Resistance is always determined between two points or surfaces, right? Here, and length is parallel to two points or surfaces, and area is perpendicular to two points or surfaces. These concepts are applicable here. Therefore, R हमें चाहिए फर्स्ट ऑफ ऑल ए बी सी डी ई एफ ए बी और सी डी और ई एफ 3 points. In this case, length will be equal to, in this case, AB. AB के parallel C है, तो length will be C, area will be remaining two sides, that is A into B. A, B. Therefore, resistance RAB will be equal to rho C upon AB. One is this answer. Second, RCD. This is parallel to this one. This is B. The length will be B. Length will be equal to B. Length will be equal to B. Area will be equal to A into C. So RCD will be equal to rho B upon AC. REF. In this case, length will be EF के parallel ये A है, length will be A, area will be BC. Therefore, REF will be rho A upon BC. So this question concept was cleared, how to identify area, how to identify length, right? Next question. Question is copper wire stretched to make it 0.1% longer. What is the percentage change in its resistance? Concept applicable is propagation of error. Propagation of error. Z equal to A की power A, B की power B, Z की power C. dz by z equal to A dA by A plus B dB by B plus C dC by C. This is the now here as R proportional to L square, therefore R by R will be equal to twice delta L by L. Percentage change will be, this is delta R by R into 100 equal to twice delta L by L into 100. This is 2 into 0.1%. 0.1%. Therefore, 0.2% is change in its resistance. Change in its resistance. Right? Next question. Till now, we have gone through concept and tricks on these topics. In further session, we are going to discuss all these. It is requested go through the session कंप्लीटली। इसी के साथ साथ मैं रिक्वेस्ट करूंगा कि अगर आपने चैनल सब्सक्राइब नहीं किया, प्लीज सब्सक्राइब इट एंड शेयर विद colleagues and friends. Not just study the question and concept. Concept is regarding temperature dependence of resistance. With rise in temperature, two effects. First, number of free electrons increases, means conductivity increases, means resistance or decreases. Second is the ions of material vibrate with greater amplitude, which in turn collision between ions and electrons becomes more frequent, means conductivity decreases, means resistivity or R decreases, right? Now, there are two effects. In case of conductor and in case of semiconductor. In case of conductor, as there are very high free electrons, therefore part 2 as above is dominant. Part 2 above is dominant. If it is dominant, then resistance increases with rise in temperature and resistivity increases with rise in temperature. In case of semiconductors, as there are few free electrons, part 1 is dominant. That means rho or R decreases. Rho or R decreases, right? Rho or R decreases. It means resistivity rho T equal to rho 0 1 plus alpha T minus T0. This formula is applicable for a range of about 100 degrees centigrade, right? And T naught is between 0 to 25 degrees centigrade, right? This is regarding the temperature dependence of the resistance, right? Now, let's start the question. Question is the resistance of thin silver wire is 1 ohm at 20 degrees centigrade. Wire is placed on liquid bath and resistance found to be 1.2 ohm. What is the temperature of bath? Alpha, that is temperature coefficient of resistance of silver is 3.8 minus 3 per degree centigrade. Now, as we know, resistivity equal to rho 0 1 plus alpha T minus T0. This is the temperature coefficient of resistivity or resistance. Now, as resistance R equal to rho L upon A. As temperature rises, L increases, length increase करती है and area में depend length and area. But for all intentional purpose, L upon A is very small and can be considered as constant. Can be considered as constant. Therefore, R is proportional to rho. Therefore, RT equal to R0 1 plus alpha T minus T0. Right? T minus T0. In future, we can use this formula directly. This was explained to understand the concepts applicable. Right? Now, substituting the values. Substituting values. 1.2 equal to 1.0, 1 plus alpha. Alpha की वैल्यू कितनी है? 3.8 10 to minus 3, 3.8 into 10 to the minus 3, T minus 20. On simplification, we get T equal to 72.6 degrees centigrade. This is the answer. Right? Next question. Question is, the current voltage graph for a given metal wire at two different temperatures T1 and T2 are shown in the figure. The temperature of T2 is greater than T1. Is this statement true or false? We have to conclude either true or false, right? Now, concept applicable in this question is slope concept. Slope concept. That is m equal to tan theta equal to y2 minus y1 over x2 minus x1 equal to dy by dx at x1 y1. In this case, this is applicable. So this is theta 2, this is theta 1. For slope, theta is the angle made by line anti-clockwise with respect to positive direction of x-axis, right? This is theta 1, this is theta 1, this is theta 2, right? Now, y upon I. In this case, slope is I upon V and resistance is V upon I. Resistance is V upon I. Resistance is V upon I. Now, as temperature increases, resistance of metal increases. That is positive temperature coefficient of resistance, right? Therefore, R proportional to T proportional to slope. Now here, slope is this one. Now as theta increases, tan theta also increases. Therefore, T is inversely proportional to slope. Inversely proportional to slope. That is inversely proportional to slope. T1 over T2 will be equal to slope 2 over slope 1, that is tan of theta 2 upon tan of theta 1. See this factor, tan theta 2 upon tan theta 1. Tan theta 2 is this, tan theta 1 is 1. So this is less than 1. Less than 1. Therefore, T1 is less than T2. Check what is the statement. Temperature of T2 is greater than T1. Therefore, T2 is greater than T1. So given statement is true. Given statement is true. Right? Next question. Question is, the variation of applied potential current flowing through the given wire is shown in the figure. The length of wire is 31.4 centimeter. The diameter of the wire is measured as 2.4 centimeter. The resistivity of the wire is measured to be x into 10 to the power minus 3 ohm centimeter. We have to find the value of x. This is the figure, right? Now, concept applicable here. This is EMF voltage. This is current. So, if you know R equal to rho L upon A, we have to find rho R into A upon L, right? Now, to find R equal to V upon I, that is M, that is tan theta, that is tan 45, that is 1. This is slope, measure anti-clockwise with respect to positive direction of axis. Substituting values. Substituting values. Rho equal to R1 into pi R square, 1.2 whole square divided by 31.4. 31.4. That is pi given to us is 3.14 into 1.44 divided by 31.4. This goes 10. This comes out to be 144 into 10 to the power minus 3. This is equal to x into 10 to the power minus 3. So x comes out to be 144. That is the answer. Right? Next question. अभी तक के सेशन में we have gone through tricks and concepts on this topic, and on this topic. Concept and tricks were cleared through illustration. Now in further session, we are going to discuss all these. Session is going to be very, very important. It is requested. Go through the session completely, not just study the question and concept. Concept regarding Kirchhoff's law. Kirchhoff's law, there are two Kirchhoff's law. Kirchhoff's current law, Kirchhoff's voltage law. इसको फर्स्ट लॉ भी कहते हैं, इसको सेकंड लॉ भी कहते हैं. These are generally applicable when circuit is complex and not possible to reduce into simple circuit. Right? KCL, Kirchhoff current law. Summation I equal to 0 at a junction. That is sum of incoming currents equal to sum of outgoing currents. Sum of incoming current equal to sum of outgoing currents. This law is based on conservation of charge. This law is based on conservation of charge. Now, KVL is applicable to a closed loop, or you can say, and based on conservation of energy. Based on conservation of energy, summation IR equal to summation E. We will discuss sign convention also. Convention through this step. Now in this case, if we start from A, B, C, D, no different path is available. That is, we can say single wire is there. No, we can move like this. Now in this case, this is higher to lower, current is from higher to lower. Higher to lower we will consider as a negative one. In this case, lower to higher, it will be considered as a positive one. So summation IR equal to summation E. Summation IR equal to summation E. That is, sign convention will, leaving point of the terminal will be assigned the sign to EMF. Current is flowing in this case, higher to lower. Leaving is negative, so minus E1 plus E2. And summation IR, we are moving the direction of this. We know current from higher potential to lower potential, higher to lower. This is the right. Then I into R1 plus I into R2. Only single variable is there, where number of wires equal number of variables required, number of equations will be required. Right? Now I will discuss when more than one wires are there. That is, different paths are there. Let's discuss that. In this concept of complex circuit, that is, when number of wires, or you can say number of different paths for flow of currents are there, then number of wires or number of, so here wires are E, F, B, A, BE and PCDE. So this current is I1, this current is I1, this current is I2, this current is I3. Number of wires are 3, therefore 3 variables will be there. 3 variables. That is I1, I2, I3. To find 3 variables, apply KVL and KCL. KVL can be applied to loop A, B, E, FA. Be careful when we write the loop, initial and final point should be same. Then we can apply loop B, C, D, E, B. Or we can apply the loop A, B, C, D, E, F, A. Bigger loop. Three variables can be obtained through this, or we can apply junction rule. Junction rule. Junction rule will say at point B. At point B. At point B will be, it is based on the conservation of sum of incoming currents equal to sum of outgoing currents. B पे I1 एंटर कर रही है, I2 और I3 लीव कर रही है. I1 should be equal to I2 plus I3. One equation we get this, we can apply KVL to these two loops and find the current in the different branches. Now, with this same example, I am going to solve in the question. Let's start with the question. Question is, find the potential difference between the points F and C. This question has been taken from the earlier one, right? Now, in earlier question, we have find it out the different currents path. This is I1, this is I2, this is I3. I1 हमने find out किया, that is 1 ampere. I2 minus 8 by 3 ampere. I3 is minus 5 by 3 ampere. I2 is positive 1. These statements. What is the concept? We have to find, we can take the path, we have to find Fm to find potential difference between points F and C. We can take this path, we can take this path, right? Means sign convention I have already discussed. Vf plus 2. Current is passing through this. Summation IR equal to summation E. So minus 4I1 minus 2I3 minus 4 equal to Vc. Vf minus Vc comes out to be 4I1 plus 2I3 minus 2. Substituting the values, 4 minus 10 by 3 minus 2. On simplification, this comes out to be 2 minus 10 by 3. On simplification, this comes out to be minus 4 by 3 volt. Negative indicates, negative sign indicates Vc is greater than Vf, or you can say Vf is less than Vc. This is the answer. Again, repeating the concept, we have to find the potential difference. We move करो, ये path follow किया हमने. We follow this path. Sign convention, leaving point of the term, assign the sign. Positive one, summation IR equal to summation D. तो ये दोनों सम ले रहे हैं तो ये माइनस हो जाएगा, ये भी माइनस हो जाएगा. वैल्यूज पुट कर दी तो we find the answer. Next question. Question is, find the currents in different branches of electric circuit. Concept of this question is discussed in the concepts, right? Now, in this case, 3 branches are there. E, F, A, B, E, and B, C, D, E. 3 wires. Means इसमें सेम करंट फ्लो करेगी, इसमें अलग करंट फ्लो करेगी, ये डिफरेंट पाथ है, डिफरेंट पाथ्स आर देयर. Then say this is I1, this is I2, this is I2, this is I3, right? Now I1, I2, I3, I1, I2, I3. Now applying junction rule, that is KCL, which is based on the conservation of charge. Sum of incoming current is equal to sum of I currents. I1 equal to I2 plus I3. Right? Now applying loop rule or KVL to closed loop A, B, E, F, A, E, F, A. Initial and final point should be same. 4I1 plus 2I1 equal to positive. Current is flowing like this. Same current. 4 plus 2, 6I1 equal to 6, I1 equal to 1 ampere. Right? Now applying KVL to loop B, C, D, E, B. First point at subtotal. This comes out to be 2 plus 4, 6, 2I3 plus 4I3 equal to positive to negative minus 6 and positive to, this comes out to be, we are considering the current like this loop. We are considering the current flow like this. This comes out to be minus 4. 6I3 equal to minus 10. I3 comes out to minus 5I3. I3, we are considering this one. Means the direction of I3 is negative. Negative shows that assumed direction is opposite of that which we have considered. Now I1 is known, I3 is known. Use now substituting I1 and I3 in equation 1. I2 will comes out to be I1 minus I3. I1 is 1 minus 5 by 3. That is 8 by 3. One is this answer, one is this answer, and one is this answer. Different loops, right? So again repeating the concept. First of all, identify the number of wires or number of different paths through which currents are passing through it. Then think of KCL, think of KVL, right? Next question. Till now, in this session, we have gone through concepts and tricks through illustrations on these topics. In further session, we are going to discuss this one. It is requested to go through the session complete. It's going to be very, very important for all these. Now let's start with the question and concepts. Concept regarding potential difference V across the terms of the battery. There are 4 cases. Battery may be open circuit. OC is open circuit. That is not making closed loop. Not making closed loop. That is I equal to 0. In that case, V equal to E. V equal to second short circuit. Short circuit means when battery is like this, it is short circuit. V will be equal to total current. Third is charging of a battery. Charging is the resistance. Current is being fed. Current is being fed to battery. In that case, this is our E plus IR. What is discharging? Discharging current is being drawn from the battery. In that case, V equal to E minus. These are the four cases of the array. We will discuss the question also. Also, we will discuss distribution of I, distribution of V in series, in parallel. In series and parallel through illustrations in the question. Now, start with the question. Question is, find the potential difference across each of the batteries B1, B2, B3, B4. Now, concept applicable and solution. We should be familiar with the terms open circuit, short circuit, charging, discharging. All these concepts will be applicable here, and KVL will also be applicable here. Now in this case, B1 is not in closed circuit. Therefore, it is open. It is open. Means no current is flowing through it. Therefore, V equal to E. That is 4. Right? In this case, B2, short circuiting. When we connect the terminals with the wire, conducting wire, that is called short circuiting. In case short circuiting, in case of short circuiting, V will be equal to 0. Total V will be equal to 0. Now, across B3 and B4, applying KVL to closed loop A, B, C, D, A. Be careful. This point and this point should be same. Then it will become the closed loop. Direction is shown here like following this. The summation IR equal to summation E. KVL has been discussed in the earlier sessions. Right? I am again repeating. Summation IR equal to summation E. Direction of flow current is this. So this is how much? 2 ohm. I 2 plus 2 plus. This is how much? P3 1. That is equal to summation E. This much is, this is 10 volt, 10 volt, 10 volt, 1 ohm. This is leaving point of the terminal is positive, the positive value, that is 10 volt. In this case, leaving point of the terminal is minus 5 volt value, right? Then 5 equal to 5, I equal to 1 ampere. Current in this loop is 1 ampere. Now check the case of charging or discharging. Charging कब होगी? Charging when battery sign is like this. This is the case of charging. Current is fed into the discharging, and current is being drawn from the battery. Current drawn from battery, and current feed to battery charging. In this case, V equal to E plus IR. In this case, V equal to E minus IR. Everything is given to you. So B3 is a case of discharging. B3 is a case of discharging. B3 case of discharging. That is, current is being drawn from battery. So V will be equal to E minus IR. 10 volt minus 1 into, how much is the 10? 1. This comes out to be, that is 9 volt. Right? Current is 1 amp. That. Now, case of B4, case of charging. That is, current is being fed. Current is being fed to battery. In that case, V equal to E plus IR. V is 5 plus 2. 5 plus 1 into 2. That is 7 volt. This is all about short circuiting, open circuit, charging and discharging, how to find the batteries. All concept has been cleared. Next question. Question is, in the given circuit, shown in figure, potential difference across 6 ohm resistance, इसके across is 4 volt. Find V and I across each and also find EM of the applied battery. Concept applicable and solution. Concept applicable and solution. You know, RP is product upon sum. That is 1 over RP equal to 1 over R1 plus 1 over R2. From this, we get product upon resistance divided by the sum of resistance. In series, I is same and V is distributed in direct ratio of resistance. In parallel, V is same and I is distributed inverse ratio of resistance. Inverse ratio of resistance. Product terms, these concepts are applicable here. Now, its equivalent circuit. Its equivalent circuit will be 8 ohm product 18 divided by 2 ohm, 3 ohm, right? This is applied here. 8 ohm, 2 ohm, 3 ohm, right? Voltage across this is given to you 4 volt. 4 volt. Now, according to this concept, this is a series. Now, it is series combination. Combination of 3 resistances. In this case, I will be same and V will be distributed in direct ratio of resistance. So V across 8 ohm resistance will be equal to, that will be, it is 4 times 4 into 4, that is 16 volt, because 8 ohm can be ratio of 4 into 2. 2 ohm के across 4 volt is across. Similarly, V 3 ohm will be equal to 1.5 into 4, that is 6 volt. So this will be 6 volt. This will be 16 volt. Right? 6 volt, 16 volt. Therefore, applied EMF will be equal to 16 plus 4 plus 6, that is 26 volt. Internal resistance considered 0, right? Then current through 8 ohm resistance, current through 8 ohm resistance will be equal to, according to Ohm's law, I equal to V by R, 16 divided by 8. 16 divided by 8, that is 2 ampere. Similarly, now voltage is known across this is 4 volt, across this is 6 volt. So current through this, I equal to V upon R, I equal to V upon R, V upon R, V upon R. We can find the current through each resistance, right? All concepts I think is clear now. Next question. अभी तक के सेशन में we have gone through the tricks and concepts on all these topics. If you have any doubt, please comment it. In further session, we are going to discuss heating effects of current, going to be very, very important for these and this. It is requested go through the session completely. Now let's start with the question and concept. Concept regarding heating effects of current. Say, number of bulbs of different powers and having same rated voltage. Same rated voltage. If they are connected in series, they are connected in series. They are connected in series. Power consumed it will be 1 over Ps equal to 1 over P1 plus 1 over P2. If in parallel Pp equal to P1 plus P2 P1 P2 means in series power brightness is proportional to power consumed of power consumed. So in series least resistance equipment will glow more brightly as resistance of that will be more. Resistance of that will be more. In series, current is same. Current is same. And resistance will be equal to V square by P. इसकी पावर कम होगी and reverse is on parallel. Reverse is in parallel case. Right? To boil water using heaters in series T is equal to T1 plus T2, sum of all the time taken individually. Individual time T1, individual time T2, total time taken will be equal to, if they are connected in parallel, 1 over Tp equal to 1 over T1 plus 1 over T2, and that's all. In all these things, provided, applied voltage is V. Applied voltage is V. Applied voltage is V. Applied voltage is V. Right? This is about, now let's start with the questions. Question is, prove that 60 watt bulbs glows more brightly than 100 watt if by mistake they are connected in series. Concept applicable. Brightness is proportional to actual power consumed. In case of series combination, current flows same. Therefore, brightness proportional to power consumed will be proportional to I square R. This is same in both the bulbs. Right? Now, as R equal to V square by P, provided rated voltage of both the bulbs is same. Then R 60 watt will be equal to V square by 60, and R 100 watt will be V square by 100. Now, from this information, as resistance 60 watt bulb is greater than R 100 watt. Therefore, brightness proportional to power consumed proportional to R. Now, as R is greater of 60-watt bulb than 100-watt bulb. Therefore, 60-watt bulb will glow more brightly. Generally, in domestic electric connections, equipments are generally in parallel, and if in parallel 100-watt bulb will glow more brightly. Right? Next question. Question is, the rated values of two bulbs are, power is P1, what is V? Power is P2, what is V? Find the actual power consumed by both of them if they are connected in series. They are connected in parallel. And V potential is applied across both of them. And potential difference applied across is V. Right? Now, we will consider first concept applicable for series combination. In series combination, you know R equivalent will be equal to R1 plus R2. In series combination, you know pi is R equal to V square by P, as R equal to V square by P. Therefore, PS, that is power consumed in series combination. Power consumed in series combination will be equal to V upon R equivalent, V square upon R1 plus R2. That is V square upon R1, V square by P1 plus V square by P2. On simplification, this comes out to P1 P2 upon P1 plus P2. This is the power consumed in series combination. It can be rearranged as 1 over PS equal to 1 over P1 plus 1 over P2. This is the formula. Number of bulbs are connected in series plus. Right? Now, for parallel combination. Now, for parallel combination, to find power consumed when bulbs are connected in parallel. You know, 1 over Rp in parallel are equal to 1 over R1 plus 1 over R2. Right? Then, in parallel, power consumed will be in parallel PP. That will be equal to V square by R equivalent. That is V square upon 1 over R equivalent. That can be written as V square by 1 over R1 plus 1 over R2. This can be written as V square by R1 plus V square by R2. This is the power of first bar, this is the power of second bar. This is parallel combination. Means in parallel, power consumed is simply algebraic summation of all equipments. Right? Next question. Question is, heater 1 takes 3 minutes to boil a given amount of water. Heater 2 takes 6 minutes to boil the water. Find the time taken if they are connected in series, they are connected in parallel. Concept applicable. To boil the water, same amount of heat is to be provided by both the heaters. By both the heaters. This is the concept. You know, M into C into delta theta भी होता है और जितना भी वाटर करता है, right? Now, H will be equal to P1 T1 equal to P2 T2. Heat will be same. Now, in series combination, 1 over Pp equal to 1 over P1 plus 1 over P2. So this comes out to be H. Pp की जगह पुट करेंगे हम H over Ts. So Ts will be equal to, in series combination, power consumed is this one. So 1 over P1 from this, 1 over P1 will be equal to T1 over H. T1 over H. So that is Ts over H. That is T1 over H plus T2 over H. Means if they are connected in series, T1 plus T2, sum will be total. In that case, 3 minutes and 6 minutes. Total time will be 3 plus 6, that is 9 minutes. This will be the answer. To boil the water, 9 minutes will be taken. In parallel, you know, P equal to P1 plus P2. From this, heat is same, H over Tp equal to H over T1 plus H over T2. That is 1 over Tp, 1 over T1 plus 1 over T2. This is the formula. Therefore, when connected, when time required, when connected heaters are in parallel, that will be equal to, Tp will be equal to T1 into T2 divided by T1 plus T2. 3 into 6 divided by 3 plus 6. That is 3 into 6 divided by 9. 3. That is 2 minutes will be taken. If they are connected in parallel, time taken will be less than that compared to the series combination. So this can be used as direct formula. This can be used as a direct formula for time taken to boil the water, right? Now, I would like to request, if you are new to my YouTube channel, Sethi Shift Learns, please like and subscribe to my channel and press bell icon to receive updates on concept killing videos. Thank you.